Welcome to Maths Guru Educational Services. If you are studying with us on Maths Guru channel for the first time, kindly click on the subscribe button so you'll be informed anytime we upload a new video on this platform. Today we are going to discuss the fourth unit in our course material. We are going to discuss this in line with, right here we have a question taken from 2020 academic session, and the question that's related to these units, question number 1, this session, Roman number 1 and 2, I lifted that here. The first question is to differentiate between nominal scale and ordinal scale. The second question is to determine the measurement scale that are used for the measurement of the data or the concepts provided here on the table: reaction rates, educational level, zip code, total score of students in TMAs for EDU821. I believe by the end of this discourse, we're going to be able to answer all these questions. And the course material, we have these objectives outlined there, and at the end of this unit, you should be able to distinguish between the 4 measurement scales, to classify data scores according to their measuring scales, to define a variable and classify a variable as either discrete or continuous. That we're going to do in this discourse, to conceptualize what kinds of analysis are possible with what types of data scores. Here we start the discussion proper. We have scales of measurements. When we talk of measurements, we refer to the assignment of numbers to objects and events according to logical acceptable rules. The numbers have many properties such as identity, order, and additivity. In 1946, Harvard University psychologist Stanley Smith Stevens developed the 4 levels of measurements in his article on the theory of scales of measurements. The 4 scales of measurements that were applying there: nominal scale, the ordinal scale, the interval scale, and ratio scales. So these are also referred to as the 4 levels of measurement scale. The nominal is the first level, the ordinal is the second level, the interval scale is the 3rd level, and the ratio scale is the 4th level of measurements. Okay, in our course material, we're given these situations to consider to enable us to understand the 4 levels of measurements. The first situation is talking about assigning the students number 1 to 30 in no particular manner or on random basis, so as long as no student has more than 1 number. In this case, numbers are just assigned randomly. Any person can take any number, and the person, maybe the person that is assigned number 30 or number 29, can as well be given number 2 or number 1. So any particular student can take any particular number, but no student should take more than 1 number. By so doing, we can identify the students based on the numbers or the number assigned. The second situation is asking the student to stand in a queue as per their height and assigning them position numbers in the queue from 1 to 30. In this case, the number is assigned based on the height of the student. So the shortest person in the class definitely will have the number 1, and the tallest person in the class will be assigned the number 30. So in this case, note that the assigning of the number is based on the height of the student. But remember that the heights are not accurately measured, in the sense that we do not know the exact height of any particular student. So we measure the height of one student in reference to the other students. Then the third situation is administering a test of 50 marks to all students and awarding marks from 0 to 50 as per their performance. I'm actually going to use this to discuss the third level of measurement, the interval scale, as we move on. So I'm not going to talk much on this. But for the first two, I'm going to use different terms to help us understand what the first two levels of measurements are about. And the last situation is measuring the height and weight of students and making the record, given a record. In this case, we take the exact height of the student, each of the students, or we take the exact weight of the students using different maybe aware balance to take the weight of the student. So we know the exact weight or the exact height of any particular student, so we can measure them. Now let's discuss the nominal scale. The nominal scale. The nominal level is the simplest level. Nominal simply means existing in name only. Existing in names only. So with nominal level of measurement, all we can do is to name or label things. We cannot perform any arithmetic with nominal level data. That is to say, no meaningful order is implied at this level. We can reorder our list of variables without affecting how we look at the relationship among these variables. For instance, male, female. If we talk of male and female, we can reorder it without affecting the nature of these variables we have. So examples of data measured at this level are the plate number of a vehicle, the religion we practice, the color of one's hair, the zip code is a nominal scale. Any particular city can be assigned in a zip code for the purpose of identification. So it is particular or specific to that particular city or state. So no two states will bear the same zip code. So it is a nominal scale. All right, we are going to discuss this third level, the interval scale, using the situation provided earlier that of administering a test of 50 marks to all students and awarding marks from that is 0 to 50 as per their performance. In this third situation, the students have been awarded marks from 0 to 50 on the basis of their performance in the test administered on them. So consider the marks obtained by 3 students. We're told that the 3 students given 30, 20, and 40 respectively. Here, it may be interpreted that the difference between the performance of the first, that is, the person with a score of 30, and the second is the same, that is 10 now, is the same as the between the performance of the first and the third student. That may be the possible interpretation. So a student getting 0 marks cannot be described as having a 0 achievement level. No, students who has attempted the test will score 0 marks, since the scores are relative to a marking scheme. We lack a non-arbitrary 0 here. That is one thing you should take note of whenever you discuss the interval scale. There is a non-arbitrary 0. The fact that somebody scores 0 does not mean he or she has not achieved anything at all in the learning process. Similarly, the second students cannot be said to have the intelligence of the third student, simply because the second has 20 and the third has 40. I think this is self-explanatory. Yes, yeah. This type of scale is described as interval scale. Here, the properties of identity, order, and additivity are applicable. The properties of identity, that is, you can identify the object or the thing or the data, you can order them, you can position this data, and you can add or subtract. You can add, subtract. Note also that the scores can have fractional values. So the examples of data measured at this level include scores of students in an examination, days on a calendar, shoe size. All these are interval scale of measurements. Then the ratio scale, which is the fourth scale of measurements. In this fourth situation, as stated in the situations given to us, measuring the height and weight of students and making wise record. We measure the height, the exact height will be taken. The exact weight will be taken. So the exact physical values pertaining to the heights and weights of all students have been obtained. Here the values are comparable in all aspects. So if 2 students have heights of 120 centimeter and 140 centimeter, for instance, then the difference in their height is 20 centimeter, because it is measured and the exact measurements are taken. So, and the heights are in the ratio. We can put them in the ratio 6:7. Some may not understand how come about these 6:7. I will quickly explain that. When we have 120:140, we can say it is equal to 20 in 120 will give 6. Then we have it ratio 20 in 140 will give 7. That is how come about the 6:7 here. Examples of data measured here are income, you know the exact value, distance traveled, measured, time elapsed or time remaining for a job to be done, also measured, and the exact measurement taken. Money in one's bank account is an example of data measured using the ratio scale. And height of a student. This time we are not talking about the height of one student in relation to another one based on the observation, mere observation. Now one is short, the other one is shorter. That is not what we are talking about here. We are talking about the exact measurement of the height of the students. All right, we have these questions given to us in the course material, and we are to determine the measurement scale that I use for each of these data. The first one is age of students of your school. We have to recall that age has a meaningful 0 points, that is at birth. From the very moment someone is born, we say the person has not attained any day or any year, so to say, and it is continuous. If you measure it precisely enough, it's continuous. Therefore, we can say that age of students of a school, of your school, is a ratio scale data, because it has a 0 points, a meaningful 0 points, and it is also continuous. So one can say I am 1 year and 3 months. That is the age of the person. 1 year, 4 months. 1 year, 6 months. Or 5.5 years. So it is meaningful if someone says something like that. So age is at the level of ratio scale. Then the roll numbers assigned to the students of a class. A roll number assigned to the student in a class. You remember we talked about that when we're discussing the nominal scale measurement. So it's a nominal scale. We just assign this in randomly. Any person can take that roll number first. Any person on that particular row can take the first number. Then C, we have the rank of students of SS3 of your school in the NECO examination. And this has been stated as we're discussing also the ordinal scale. When we're talking of rank, we talk of the ordinal scale: first, second, third, fourth, fifth, sixth, and so on. Then the mark obtained by the student of JSS in introductory technology. So what is the scale level for this? It is simply the interval scale. It's at the interval scale level of measurements. Then the E parts, we talk of the group of SSS students. And this is just a nominal scale. The group, they are identified by the group, just name. So when we talk of name and identity stuff, we are referring to the nominal scale. Then for F, we talk of later grades A, B, C, D, E. You can try this yourself before you hear whatever I'm going to say. It is an ordinal scale. It is an ordinal scale. I believe your answer is same as mine. Then the G aspect, we have amount of money with the students in the class. That has been answered as well as we're discussing. Please, if you've forgotten, you can take your video back there as many times as possible, listen to that particular aspect again, and he will answer it correctly. So I'm not going to answer that. Then H, the nationality of participants in an international conference is just like the group of SS students. Talking of nominal, you are naming them or identifying them by the nation, the nationality. Then courses in which students are registered. Courses in which students are registered. No difference from what we have said in H. So it's still a nominal scale measurement. Show size of JSS1 students in a federal government girls college. This I will leave you to answer as well. It has been answered in the discussion. Then we have number of books on the shelf. That has been answered as well. It's numeric. You can take the accurate measurements. So I'm just giving you a clue there. Have the accurate measurements. Accurate number. You can count. You can determine whether there are 4, 5, 6, 7, 8, or 10. Anyhow. So just answer that yourself. And if you cannot answer it, go back to what we have discussed so far. It means you have not understood our discussion all the while. Then L, enrollment of children of school age in a local government area. That has been answered as well. Please go back to what we have discussed so far, and you will get to understand that the size of a family, number as well, a height of school children. That's not answered as well. So please kindly take your video back as many times as possible so you can answer these questions, the ones that I did not answer yourself. Okay, we move to the next. Okay, is 2020 examination question that we stated earlier. Differentiate between nominal scale and ordinal scale. Now, nominal and ordinal scale. I believe you should be able to do this yourself now. If you cannot do it, please take your video back and listen to that aspect again. You will know the difference between the ordinal and the nominal scale, or the nominal and the ordinal scale. Which of the scale, the nominal, ordinal, interval, or ratio, is being used in the concept listed below? And the concepts are reaction rates. When we talk of reaction rates, we talk of the concentration of certain substance per time taken. The concentration of something, the increase in the concentration or the decrease in the concentration of something per time taken for that to take place. And by so doing, we know that is a ratio scale. Then educational level, that has been answered as well. Zip code answered as well. Total score of students in TMAs for EDU821. I believe that is answered. Please comment below the video and tell us what your answer is. If it is not correct, we'll try to explain more and more for you to understand. Okay, here we have qualitative variable. A qualitative variable is one which can be described by assigning names such as male or female, class 1, 2, 3, 4, 5, 6, and whatever. Qualitative variables usually take on finite sets of values. That is, you cannot associate fractions with qualitative variables. The measurements are discrete. Being discrete simply means they are separate, they are distinct. They are distinct. Thus, discrete data are associated with either nominal or ordinal scales of measurements. So you can only define discrete data, identify discrete data of this. You can also order them, but to talk of measuring their actual value is not possible. You cannot measure their actual value. You cannot talk of their relation to order in terms of the actual measurements. So that is qualitative variable. Qualitative variable. But when we talk of quantitative variable, talk of quantitative variable. A quantitative variable is one which can be measured using an acceptable scale and procedure to assign numerical values. Quantitative variables usually take on continuous set of values. Value changes with time. The volume of water can be measured using measuring glass. Grains can be measured using the module. Body temperature can be measured using thermometer. In all these cases, the values can have fractions, and the fractions are meaningful. The fractions are meaningful. You can say somebody's temperature is 37.5 or 37.5. It makes meaning. Somebody's weight is 50.8, 50.73. It is meaningful. Thus, continuous data are usually associated with interval or ratio scales of measurements. Here we have parametric versus non-parametric statistics. What we simply want to do here is to differentiate between parametric statistics and non-parametric statistics. This course so far has made this very simple. We have discussed quantitative variable and qualitative variables. All right. You recall that we cannot do much mathematical operations with the figures derived from qualitative data. And so the statistical analysis which are associated with qualitative data are described as non-parametric. On the other hand, if the measurement is about an object or event that is continuous, that is discrete or separate data, such as time, weights, height, scores in a test, temperature, and intelligence, then the data is continuous, and the statistical analysis is quantitative. So the data involved in this kind of measurement can be added or subtracted, multiplied or divided. The statistical analysis which are associated with this kind of data, that is the quantitative data, are described as parametric statistics. Thanks for studying with us. Please subscribe, comment, like, share, and suggest ways of improvement so we can serve you better. Again, thanks, and don't forget to subscribe.